In this video, we're going to take a look at verifying trig identities. So an identity is an equation that is always true no matter what value you put in for the replacement value. So if I have a trig identity, if I have sine x, then I'm assuming that the equation is true for any value of x. No matter what I substitute in, it has to be true. And we have already looked at some identities. So we looked at the reciprocal identity. Sine is always going to be equal to 1 over cosecant. All right, we looked at ratio identities. We know that tangent is sine over cosine, and we looked at these Pythagorean identities. So what we're going to do with those is, given a statement like this, secant of x times cotangent of x is equal to cosecant of x. We are going to verify that this is true, that no matter what value we subbed in for x, this would always be a true statement. And the way we're going to do that is to make both sides look the same. So we're either going to change the left side so that it looks like the right side, or change the right side so that it looks like the left side. Something that is very important for you to know. Verifying identities is not the same as solving an equation. So we're not trying to solve for x. We're not trying to get something by itself. I can't add the same thing to both sides. I can't multiply both sides by the same thing. All right? You can't use the same techniques that you used for solving equations. So what can you do? Well, here are some guidelines, okay? And I say guidelines because I can't give you a step-by-step process that will work for every problem. Each one of these are different, and you kind of just have to look at it and just kind of try something and see if it works. But these are some things that if you look for these, there's patterns, and these usually appear. That'll give you a good starting place. Look for a common factor, something that you can factor out. All right, look for Pythagorean identities, especially anytime that you have angles or trig identities squared. Because remember, all our Pythagorean identities have squared, sine squared plus cosine squared. Fraction tricks, we'll talk about what those are in a second. If you can't figure out anything to do, then a good place to start is to change everything to sine and cosine. All right, so rewrite every trig function that's in your identity as sine and cosine. The last point, I cannot stress enough, you need to just try something. Okay, these are not problems where you could look at it at the beginning and figure out every step in your head before you start writing. You just got to go do something and then reevaluate after each step, and eventually getting to what we're looking for. Okay, so here is this example, and if I run through that list of guidelines that we have from before, there's no common factor, and there's no Pythagorean identity here because nothing is squared. So what I'm going to do is change everything to sine and cosine. And when we're verifying trig identities, we can only change one side. So I'm only going to change the left side of this equation, not the right side. Okay, so secant, right, rewriting secant in terms of sine or cosine, secant is equal to 1 over cosine. All right, that is a reciprocal identity. So over here, I'm always going to write what identities or what I'm doing, how I'm changing the equation. All right, and then cotangent, well, cotangent is always equal to cosine of x over sine of x. All right, that is one of our ratio identities. Alright, and it's still equal to cosecant of x. Alright, from there, if I'm multiplying these two and I have a cosine on the top and a cosine on the bottom, they can cancel out. So what I'm left with is 1 over sine x, and that's still equal to cosecant x. And all I did there was simplify. Alright, simplify fractions. Now, remember, I'm trying to make the left side look like the right side. 1 over sine, well, that is cosecant. That is a reciprocal identity. All right, and I'm just abbreviating reciprocal here. So now this is how I end every problem with a trig identity. I have cosecant x equals cosecant x, so I always have the same thing on both sides of the equal sign. So you're going to do your work over here and justify your steps in the right column. So why don't you give this one a try? See if you can get cosecant x times tangent x equal to secant x. So go ahead and pause the video here, give that problem a try, and then come back and check your work. Alright, so here's how I worked through that problem. This is not necessarily the only way that you can solve these. Many identities have more than one way to be verified. As long as you, every step is mathematically correct, it's mathematically equivalent what you do from one step to the other, and you end up with the same thing on both sides of the equal sign at the end, then you are correct. Okay, so let's go through this example. I have cosine x minus cosine x sine squared x equals cosine cubed x. Alright, here is a case where we do have a common factor. There are two terms and there's a cosine x in each term. So what I'm going to do is factor that out. So if I factor out a cosine x, then I am left with 1 minus sine squared x. Alright, and it's still equal to cosine cubed. Okay, and I factored there. Alright. Now, you might have been thinking, well, what about the sine squared? Isn't that a Pythagorean identity? Yes, we can make a Pythagorean identity here. So, the Pythagorean identity that we have is cosine squared plus sine squared equals 1. And I have 1 minus sine squared. Right? We can manipulate and change this identity so that it matches what I have in my equation, so I can make a substitution. So, if I were to subtract a sine squared from both sides, right, my new identity would be cosine squared equals 1 minus sine squared. Okay, that's what I have here. So I can replace 1 minus sine squared with cosine squared because they are equivalent. So when I rewrite this, I'm going to have cosine x times cosine squared x equals cosine cubed x. Okay, so again, this is a Pythagorean identity that you have on your reference sheet, all right, that we've already proved to be true. And I can manipulate it a little bit so that I get a different identity that's still true because all I did was change where things were written. So that step there was a Pythagorean identity. All right, I'm going to abbreviate. And now, well, cosine x times cosine squared is cosine cubed. Okay, all I did there was multiply those out. Have the same thing on both sides. I am finished. Okay, here's our next example. We have 1 plus sine x over cosine x equals secant x plus tangent x. Okay, no common factor here, no Pythagorean identity. All right, what I'm going to do is on the left side, let me show you, this is one of these fraction tricks that I talked about. I can actually take this fraction and split it apart as 1 over cosine x plus sine x over cosine x. Okay, and it's still equal to secant plus tangent. Alright, so because if I were to put this back together, they already have the same denominator, so 1 plus sine x over cosine x. So all I did was split the fraction apart there. Alright, so that's what I'm going to write over here. I split the fraction. Okay, then I'm trying to get this equal to secant plus tangent. Well, 1 over cosine is secant. Alright, that is a reciprocal identity. And then sine over cosine is tangent. Alright, because that is a ratio identity. And then we're done. Okay, let's look at one more example. So here I have cosine over 1 plus sine x plus 1 plus sine x over cosine x equals 2 secant x. Alright, here I don't have common factors anywhere. If you're thinking that you can cross these out or cross the cosines out, you can't do that because we're adding the fractions and not multiplying them. Alright, the only thing I can do to simplify fractions is when I add them together, they need to have a common denominator. So this one is 1 plus sine x, this one is cosine x. I need them to be the same so that I can add them together. So to do that, I'm going to multiply them by each other. So I'm going to multiply this times cosine x on the top and the bottom. And then I'm going to multiply this fraction times 1 plus sine x on the top and the bottom. Okay, so when I do that, now I have cosine squared x over 1 plus sine x times cosine x. Okay, and then over here, 1 plus sine x times 1 plus sine x, I actually have to FOIL that out. So 1 times 1 is 1. 1 times sine x is sine x, and then I'll have 1 times sine x again, so I'll have 2 sine x. And then sine x times sine x is sine squared x. And this is all over, again, cosine x, 1 plus sine x. Alright, so if I multiply those on the bottom, I'm just going to leave it like that. And it's equal to 2 secant x. So I was getting a common denominator there. Alright. Now, on top here, okay, I don't have any like terms that I can combine, but cosine squared plus sine squared is a Pythagorean identity. Alright, cosine squared plus sine squared is equal to 1. So now I have 1 plus 1 plus 2 sine x. Alright, I have the whole fraction added together. Cosine plus sine is 1, and then 1 plus 2 sine x. And again, that is over cosine x, 1 plus sine x. Okay, so that was Pythagorean identity. And then 1 plus 1 is 2, so I'm just going to put those together. So 2 plus 2 sine x over cosine x, 1 plus sine x. Alright, that would just simplify. Okay, what can I do now? Well, on the top, 2 plus 2 sine x, I can factor out a 2 there. So if I do that, I have 2 times 1 plus sine x over cosine x, 1 plus sine x. Alright, so I factored there. Okay, now everything is multiplication, so I can cross out my common factors. So I have 2 over cosine x. Okay, and again, the whole time, I forgot to write this, but this is equal to 2 secant x the whole time, because that's what we're trying to make it look like. Okay, so this was simplifying again. So now, again, we're trying to get this equal to 2 secant x. Alright. I know that I have cosine on the bottom, and 1 over cosine is secant. So I'm going to rewrite this as 2 times 1 over cosine x. Alright. Hopefully you can see that those are equivalent. Alright. 2 times 1 over cosine would be 2 over cosine. And 1 over cosine is secant, so I have 2 secant x equals 2 secant x, which is exactly what I wanted. And I use a reciprocal identity there. Okay. I know that we went through that kind of fast, and it's a little bit hard when you can't stop me and ask questions, but please write down anything specifically or put a star by it that didn't make sense to you so that you can ask about it when you come to class.